Good evening, First Robotics community. My name is Sean Lim, and I am the Director of District Implementation for First Robotics Canada. And I'm also joined this evening by Paul Keenan, our first senior mentor, also here at First Robotics Canada. Paul, how are you doing this fine evening?
I'm great, Sean. Thank you very much. And you?
Not too bad. These webinars are always good nights, an opportunity to share some really good knowledge from some guest panelists. And for our December 5th edition, we've got, I think, a pretty popular one. We're going to talk about the different programming options that are available to First Robotics competition teams. And once again, sort of following the trend of last week's webinar where we talked about computer-aided design options, we have some great free options for programming your robot. Namely LabVIEW, Java, C++, and a little known one called Python, which is a little different than the rest because it's actually not an officially supported one. So we'll talk about that in a little bit more detail. But we're going to take an opportunity to, first of all, show you where you can download all of your programming tools, kind of regardless of which one you choose. I'll show you how to download for free all four of these options. And then we've got some great guest panelists with us this evening with experience in, I think, just about all of these options, where we'll be able to pick their brains a little bit about what they use on their teams, why they've chosen to use it, and some of the pros and cons for those particular options. And so we'll actually get right to it. And so we're joined this evening by three guest panelists, the first of which is Becky Linton. Becky and I actually went to university together at Kettering University, formerly known as GMI, General Motors Institute in Flint, Michigan. And Becky is a former mentor of FRC Team 2832 out of Livonia, Michigan, and they are the Livonia Warriors. Becky, thanks very much for joining us. And Becky, if you don't mind, could you tell us just a little bit more about yourself? Sorry to put you on the spot.
Oh, no, you're welcome, Sean. For 3 full years, I was the lead programming mentor for that team in Livonia. And actually, I've kind of stepped back down, and I'm currently running Junior First Lego League at my children's elementary. So I had kids, and I'm restarting, and then I'm working my way back up to FRC again. And
Awesome.
my full-time job involves LabVIEW. So.
Awesome. And so you're known as you're what is known as a LabVIEW champion, and you're also a certified LabVIEW architect, correct?
Yep, that is correct, Sean.
Awesome. Well, glad to have you on the webinar with us. And we're actually joined by Mark Balla, who is a current mentor for FRC 4296. And they're based out of Derny, Illinois, and they are Trident Robotics. Mark, would you mind telling us just a little bit about yourself as well?
Sure. I've been in FRC since about 2006, and I've been with the current team. This will be my 3rd season with my current team in Derny, Illinois. Professional LabVIEW developer since 1998, and I've been working as a control systems advisor for Chicago, Wisconsin, and Peoria the last 3 years.
Awesome. So a lot of LabVIEW expertise on the call, which is actually something we're not used to a whole lot up here in Ontario, because as you'll hear from our other guest panelists and even myself, I don't think either of us are too familiar with LabVIEW. So we're really thankful to have that expertise on board, because there might be some teams who might be attracted to what that programming language has to offer. But thanks for being on board with us, Mark. Really appreciate it. Also joining us tonight is Kaleb Dodd, who is a mentor for FRC Team 1114. You might have heard of them before. They are Symbotics, based out of Governor Simcoe Secondary School in St. Catharines, Ontario. Kaleb, would you mind telling us just a little bit about yourself as well?
Yeah, I've been in FIRST since 2013. I've been programming since 2014, and this is my first year being a programming mentor for the team. We've been using Java since I think you've been able to use Java in FRC, so that's where most of my experience is with.
Awesome. And this is a bit of a different one because I myself am a former lead programming mentor for team FRC 610, Crescent Robotics out of Toronto, Ontario. And my expertise is predominantly with Java, but in some of my former past lives and past teams, I've done some work on the C++ side as well. And so I think it'll be a really great discussion between the four of us here regarding the different options which are available. And so we're just we're going to dive into it just a little bit deeper, because before we start discussing the different programming languages which are available, one thing I really wanted to get out of the way was, well, if you're a new team and you want to get a head start on programming, first of all, where do I get these programming tools? Like, regardless of which of those 4 options, LabVIEW, C++, Java, or Python, why don't you spend some time there, Sean, and tell us where to download them all, and maybe even what they look like. And so I've got a link up here, and that link will actually lead you to this page, which I've got to give my little disclaimer. This is the 2016 FRC control system, and so this information will be out of date when the new game is released. But it's still going to be very similar. Generally speaking, from the programming tools, we don't see a huge change from year to year, at least not lately. And so if you actually do a Google search of FRC control system, you don't even have to worry about the year, but FRC control system, this will be the first hit. And it's really, really nice, because right on this landing page for the FRC control system, if you actually, sorry, I'm not on the right page, but FRC control system, on the landing page, if you just scroll down to this second section here, under programming languages, you'll see 3 of the 4 options. And these are the officially supported options, which are C++, Java, and LabVIEW. So just as an example, if you wanted to download the tools for C++, if you click on that, for the C++ programming language, the very first section is basically installing Eclipse, which is the actual program that you use to program the robot. And if you click on that and basically just follow these instructions, it'll show you exactly where you need to go to download Eclipse and install it. And likewise, on top of that, you'll need to install what's called the FRC 2016 Update Suite. Just be a little bit careful here. I know it's called the Update Suite, but it's not actually an update. It'll install everything you need to get going with C++. And just moving along with Java, exact same type of landing page. They're going to tell you to install Eclipse, the Update Suite. And for Java, there's an extra step, because you actually have to install Java on the actual RoboRio, which is the control unit that goes on the robot. And so there's a third step there, making it just slightly more complicated. But again, if you literally just click on these links and follow the diagrams and the step-by-step instructions, they'll step you through the complete process of getting those tools. Last but not least, on the officially supported ones, there's a LabVIEW section as well. And again, if you follow through these links, it'll show you how to download and install everything that you need. As an aside, there's one other programming language which is not officially supported, called Python. And that has been put together by a group in the community. And we'll talk about why they've done Python later on, but the name of that project is called RobotPy, so RobotPy. And if you just do a Google search on that, again, this one's a little bit more complicated, where there isn't quite a nice laid out set of step-by-step instructions with pictures for you. But if you're looking for where to download it and what it's called, it is indeed called RobotPy. And so just to give you a little breakdown very, very briefly about what those 3 different options look like for you. For those of you who are not too familiar with programming languages, C++ and Java are what are known as text-based programming languages, which really are probably what most of you think about when we talk about computer or robot programs. They're basically relatively dense blocks of text, which here's an example of a C++ program with a bunch of curly braces and some funny-looking indenting. You might have seen code like this before if you're at all familiar with programming. And similarly with Java, again, text-based, just a block of code here. LabVIEW is a very, very interesting one, where you don't program by writing out lines of code in text like this. But for LabVIEW, and why it might be so intriguing to some, is that you actually program graphically, where you kind of drag and drop these little icons and you connect the lines. And every icon represents a different component on the robot or some other logical function. And you kind of just piece all the wires and the blocks together in order to get a program. And so our LabVIEW guests will probably be able to delve into how this works in a little bit more detail than myself, because I don't have that much experience with it. But those are just what your general programming choices look like. And so I think that pretty much covers where to get your programming tools. And I'll have this link in the YouTube archive for you to be able to pick up at the end. But once again, you can just search for FRC control system, and that'll give you that landing page to be able to find them. But now that I've spent a little bit of time just to tell you guys where to get these programming languages, I'm sure there's a pretty big burning question, which is, all right, well, Sean, you've shown us where to download those 4 different options. I'm a new team. Which one am I going to choose? Like, which one is probably the best one for me? And having said that, I'd like to hear from all the panelists. I'm curious to know what programming language you use on your teams, and why you may have chosen to use that language. And so I'll send this one first to Becky. I guess I know that you used LabVIEW on your team, but maybe give us some background as to how you made that decision.
Yeah, sure, Sean. The main reason we went with LabVIEW is it was actually a rookie team. This was their first year. They had 0 programming experience, 0 programming mentors. Some of you might be familiar with Michigan area automotive industry. Obviously, it's very mechanically heavy, but there's not a lot of electrical engineers or programmers that stick around, it seems like. So I, being a LabVIEW expert, went right in and suggested it. One of the reasons I suggested it for the kids is I've done a lot of C++ and Java programming myself, and I always get messed up by some syntax error. I can't spell, I got an extra space, that always messes me up. And so that's one of the things that attracted me to LabVIEW and that attracted the students. I'm like, look, you guys can focus on what you're trying to get the robot to do instead of the syntax of the language.
Very interesting. Some really good insight there. And that's not the first time that I've heard that in terms of LabVIEW being a good choice for a team without a whole lot of programming experience. But I'm going to swing this one over to Kaleb, because I know you guys are probably pretty loyal to Java, and you guys, Symbotics in particular, is really identified as a high-level team. Kaleb, do you want to give us just a little bit of insight about why you guys might have chosen Java? And I know it's kind of before your time, but you've even chosen to stick with it, so there's probably some reasoning there. But what's the reason behind that one, Kaleb? Give us some background.
The primary reason is that one of our mentors, who actually is now the teacher for programming at the school, he teaches in Java, and his main experience was in Java. And we just find, I think Java, it's pretty easy to just make, a basic robot in one file for those rookie teams. But then if you want to do something more complicated with, multiple files, multiple classes, then you can also step up to that level without, having your screen full of a bunch of graphical stuff. And yeah, so I think when you're trying to choose which programming language you want to do as a team, the biggest thing to take into consideration is the experience level of, if any one of your mentors has experience in a language, then it's probably best just to use that one. Otherwise, possibly what teams in your area use, so you can get help from them. That would also be a good thing to consider.
Oh yeah, and I think we'll definitely touch on both of those points. And you might be surprised to hear from all of us sort of where we stand on that if we were to start new teams, rookie teams from scratch, with or without experience. And so really great insight, Kaleb. Mark, I know the answer to which which programming language you use on your team, but give us some background on your end in terms of how you made that decision.
Well, when I came on, the team was using, they were using Java, or they wanted to use Java. So we let them use Java, and the only thing I requested is that I teach one LabVIEW class, so they had a better background in both text and the LabVIEW programming language, and then I just let them go. And what happened was there's like 3 or 4 students that went off and tried the text-based, and then 1 or 2 students that went off and tried LabVIEW. And by the end of the season, the kids with the LabVIEW programming language were able to do more, and they actually sold the other 4 kids on using LabVIEW that season.
Really, really interesting. Awesome. Well, I'd like to share just a little bit of my experience. When I first started mentoring programming in FRC, it was with Team 188, and C++ was kind of the major text-based language available at the time. And we chose that because it was still, and still is, probably the most popular programming language, particularly in the software development, application development industry. And so we just kind of felt that, hey, if we bring our kids through, 4 years of C++, and if they want to become programmers or software developers in the future, it gives them just a little bit of a head start for a really, really popular, obviously text-based programming language out there. And so we felt that it was a pretty good fit. But then we ended up switching to Java, particularly on Team 610. And the reasons behind that were actually really interesting. Team 610 is based out of Crescent School, which has a very, very extensive advanced placement program. And so having two Americans here on the call as well, you guys are probably pretty familiar with advanced placements, but AP Computer Science is Java. The AP Computer Science exam is basically written in Java, and that's your one and only programming choice. And so we had a number of students who were interested in doing that, and we figured, well, if we do 4 years of Java through FRC, we kind of kill two birds with one stone, where we're prepping them for an opportunity to do that AP Computer Science exam. And the other part of it was also really interesting, where we had a lot of programmers who wanted to also be part of our strategy and scouting team, and our strategy tablet application became a really interesting thing, where our programmers naturally wanted to develop a scouting app. And so we looked at iOS devices, and then we looked at Android devices, and which ones were a little bit more friendly for a student to break into the market, particularly a student without a whole lot of time, money, or I should say money or resources. And the Android platform looked pretty good, and surprisingly, the Android development platform was all Java. So some reasons from my perspective as to why we ended up choosing Java on that one. But those are our teams and what we chose, but that may not apply to your team, because when we talk about teams who might be listening on this call, there's probably a few rookies who are trying to make this decision right now, and you're not going to be in the same shoes as an 1114 or 610 or 2832 or 4296. And so this one I'd like to pass around to everyone as well. If you were a rookie team, and let's say you didn't have a whole lot of programming experience on your team, and I know you touched on a few of the points here, but which one might you choose, and what things might you consider regarding this one? And Kaleb, you touched upon this one, but Kaleb, let's say you're stepping into a rookie team, you've got nothing. Which programming language would you probably choose?
So if it was me, like, mentoring that team, I would probably do Java because I have the most experience with that. But if it was, if everyone had no experience with programming at all, then I would probably still, it might be biased, but I'd probably still choose Java, just because there's a lot of really good websites and YouTube videos you can watch to figure out the basics of Java. And like you said, where a lot of things are actually in Java, and C++ as well, but that's the thing, C++ and Java, they're both text-based languages, and they're both fairly similar. If you know one, you can, it won't be too hard to use the other one. But the reason I would use Java instead of C++, for a lot of people, it just comes down to like personal preference, but and experience. So that's why we did Java. But yeah, I would probably stick with either Java or C++ if I was a rookie team.
All right, very nice. Thanks very much for that. And Becky, we'll swing this one over to you. Brand new team, no programming experience. Where would you direct them?
I guess I'm the same in the aspect of, if you have a mentor with experience, definitely go with your mentor. However, of course, I'm going to differ. One of the reasons I would, of course, say use LabVIEW is actually National Instruments provides the RoboRio, or they make the actual hardware, and National Instruments also makes LabVIEW the programming language. So it's not as open source as Java or C++, but there is a career out there for it, if you will, as well as, to me, it's very tightly tied together, and I think Mark might bring this up a little bit later, but National Instruments has done a really good job putting tutorials and stuff together in the LabVIEW code. So if you open an example, it's got wiring diagrams, and you're ready to go, because it is all graphical, it's very visual.
Mm-hmm. And I think I'll jump in on this one because, my opinion on this one might seem a little bit surprising to a lot of people, but, I am a computer science teacher. I used to do this for a living in the classroom. And if you kind of dropped me into a rookie team with no programming experience, and Kaleb, I'm going to qualify this by saying, let's say I'm not able to mentor them myself, and I just had to give them a suggestion. Given that there's no programming knowledge or no programming mentors, I'd probably direct them to LabVIEW. And I sort of say this because, I think a lot of us who do text-based programming languages, we take for granted a lot of the background that's really required in order to get off the ground programming for the very first time. I mean, even just describing a variable and what it does, and even your basic control structures, we certainly do take them a lot for granted. And having taught those classes where I'm teaching students that for the very first time, it's a lot to invest, especially when you're trying to cram everything into a 6-week build season. I've had a limited amount of exposure with LabVIEW. I did use it doing an alpha test for the brand new control system, the RoboRio, in fact, back in 2013-14, that time period. And it was really funny because when we first were exposed to LabVIEW, we really could not handle it because we were so ingrained with our text-based programming mentality, and we struggled. We struggled to do even the simplest things. And I sort of recall an exchange with our lead programming student at the time, Ian Lowe, who's currently studying computer science at Carnegie Mellon. So he was a pretty bright guy, but we were amazed at kind of how difficult it was to do the simple stuff. But then once we finally got used to it, and we were in New Hampshire doing this alpha test, and we just kind of sat there and said, okay, well, we finally got the basic functionality of the robot working. Let's just try and do an autonomous mode just for fun, just to see if we can do it. We actually ended up putting together a really, really good autonomous mode, which had multiple parts of the robot all moving at the same time. So parallel tasking, which for those of you listening in who do have programming experience, and if you ever tried to program a robot with parallel tasks, like multiple things going on at the same time, say you're trying to drive forward and move your arm at the same time, a certain distance and a certain speed, and it's really hard to do. But for LabVIEW, it was really interesting because we just kind of dragged a few blocks around, and about 15 minutes later, we had this program that could do it. So with no programming experience at all, I'm pretty amazed at how far you can get with LabVIEW. But if you did have a programming mentor with pre-existing knowledge of any one of these programming options, that kind of takes the cake. If you have someone who knows Java, if you have someone who knows C++, if you have someone who knows Python even, I think that pretty much makes the decision for you. And that pretty much will override almost every other consideration. My apologies, because I'd like to move on to a few more questions, Mark. I didn't get a chance to get around to you, but I promise I'll get to you for a few more questions. But for those of you who've got a better idea on what programming language you'd like to choose, now you're in the situation where, okay, how do I learn this language? What if I don't have a whole lot of resources available to me? I don't even know where to start. But Mark, maybe I'll send this one over to you. In your experience working with these FRC teams, what's been the best way just to learn how to program one of these robots?
Well, for LabVIEW, we are finding the number one thing that I always, when students are trying to do something new with the robot or even old, is the first thing I'll tell them to do is go find an example. LabVIEW has a built-in example finder that has the code already there, and you're able to just bring it up, and on the front panels of these programs, it actually shows you the wiring, how you would wire it to the CRIO, and you can, as long as you're connected to the CRIO, you can download it and start running immediately, which is kind of a good motivator to keep everybody interested. The other thing that's what we are doing is if I have more than 2 or 3 programmers, it's really hard to ask the team to give us the CRIO or the RoboRio so that we can program, and also you can really only do it one person at a time. So LabVIEW actually has a built-in simulator. I think maybe Java does too, but we are using the simulator, which is a simulated robot that they put in an arena for you with some barrels and boxes, and you're able to learn how to program a robot virtually before you touch any hardware. We have found that to be immensely useful in preseason in getting things up and running and just getting everybody familiar with the different ways to program the robot.
Awesome. Kaleb, I'm going to swing this one over to you because, for the Java resources, it's a little different, but in your experience, and you went through this not too long ago as a student on robotics, right? What was the best way to learn how to program? And I guess in your case, using Java.
In my case, what I did is we actually on 1114 do vector robotics as well. So we ended up using Robot C, so that was in like a C text-based language. and a lot of that stuff, like making variables and all that, carries over into Java pretty nicely. And obviously learning from mentors and, grade 11 and 12 students of how we structure our code specifically. But like you said, with Java and C++ as well, there's a lot of background information that you kind of need to understand with variables and functions and if statements and all that kind of stuff. So to learn that kind of stuff, which you probably want to know before you start making code for your robot, there's definitely, like, I don't have any off the top of my head, but there's definitely some good online resources to learn the basics of Java.
Yeah.
And then to learn it for robot-wise, a lot of teams actually post their code. We did for 2015. 254 does for the last couple of years. They posted their code, so you can check that out. And obviously, our code would be more complicated than what a rookie team might want to end up doing. But it's just good to see where you can take the code for your robot and kind of what the most complicated scenario would be.
Awesome, Kaleb. And I'll say just kind of generally, sharing some of my experience being, the best way to learn. For the younger teams and the rookie teams in particular, those of you who are able to participate in the quick build, which is happening on kickoff day, and there's a few of them happening throughout the province, one of which happening at Crescent School, my old school. That's a phenomenal way to learn how to program your robot, because you'll have a robot that you'll have built on that day, and you'll have a chance to program it for the very first time. And what you'll really have that's important is a mentor from a veteran team beside you who will be able to show you and physically step you through that process. Tutorials are great, but I'll still say that a tutorial can only get as good as it can. There's almost no replacement for being able to spend time with a mentor or a student even who's done this before. And so for teams who are looking for an opportunity, the quick build is the next formal opportunity happening here in Ontario. But beyond that, I would also say get in touch with a veteran team. And Kaleb actually mentioned this prior. It's not a bad idea for you to find out what programming language or suite that they're using. And particularly if you're going to be able to grow a good relationship with them, which you should do, by the way, and this has come up on a lot of different webinars. Most teams in FIRST, they're all about helping out young teams, and to be able to either have you over at their facility to learn how to program, or to send a student or a mentor or both to your school to step you through that process, is one of the absolute best ways to learn. But having also just reiterated both what Mark and Kaleb said, you'd be surprised at the built-in tutorials for both LabVIEW and for C++ and Java. It's really interesting. The moment that you do file new project in basically any of them, you'll find some example projects there, which basically gives you code for a very basic robot, how to get it to drive, turn, and actually all of them also have basic autonomous programs as well, built right into the programs the moment you open them and try and start your first project. It literally asks you, would you like to see some examples and tutorials? All right, that's awesome. Thanks a lot, guys. I've only got 2 minutes left, and so I want to jump to this next question here. During your programming mentoring exploits, I'm sure you have come across just some favorite tips or tricks or just really cool things or time savers or whatever that you've run across while doing this. And so if I could swing around, Becky, could I maybe pick your brain on this one? Have you come across any of your favorite programming tips or tricks working with these FRC teams?
Yeah, I'm actually going to jump ahead to something we probably won't have time for, but I just want to mention it. And a big tip in general is to use source code control in my mind.
Yeah.
So that if you do make a mistake or do something, it's easy to back out of, and you don't have to have save as and manage your versions that way. Just look into different options. Each language has their own. Subversion's pretty popular with LabVIEW, and I think it's used for the other languages as well. But that would be my biggest tip or trick to make sure that don't ignore that.
Yeah, and I'm going to jump on that one because I think that one is so important no matter which one you use, but it's nice to know that if you're a LabVIEW team, there is something called version control out there, and what it'll do is it'll automatically save sort of old copies of your program as you make changes to it. And not only that, there's another, maybe even more benefit to version control, which is it allows multiple people to sort of check out a copy of the program, and you can all make changes to it in parallel. And then when you sort of update the master copy, it will merge everyone's changes sort of seamlessly. Maybe I shouldn't say super seamlessly, because sometimes you run into some conflicts there, but it's way easier and way better than you trying to manage that whole process manually. But if you're curious, that is something that is called version control. And specifically, Becky just mentioned one of the most popular packages out there. It's called Subversion, and I wish I had a slide with this that named it. But Subversion, I know it can be used with just about any programming language, and some people are surprised to hear that LabVIEW, being a graphical-based programming language, can support something like version control. And learning from you just today, Becky, that yeah, LabVIEW does if you use Subversion with it. Kaleb, I'll swing this one over to you. Any tips or tricks that you've come across?
Yeah, so version control, like you guys said, is a very big thing. We use GitHub or Bitbucket for our version control. A lot of teams, like to start using encoders and other sensors for the autonomous modes, but it's also good to know when it's better. Sometimes it's better off to use time. So especially this year with the defenses, it's going to be hard to get, sometimes your wheels might be off the ground, and so the encoder will lose track of your position. Sometimes if you're just trying to get over a defense, it might be a little easier. And we actually did it for our first event. If you believe 114 used time for an auto, but we used timer-based autos to get over majority of the defenses for our first event.
That's a really interesting one. And we'll say not even with encoders. And for those of you who don't know what encoders are, they're just these little sensors that you mount on generally the wheels of your robot, and they just detect how much your wheel has rotated so that you can use that in your program and sort of say drive a certain amount, a certain distance, a certain number of wheel rotations. And yeah, just to kind of highlight Kaleb's point, sometimes you can actually get so enamored with using as many sensors as you can that it actually makes things a little bit more complicated. And sensors fail, and sensors sometimes give you bad reads for one reason or another, such as if the wheel slipped, just as Kaleb had mentioned. And there's one sensor in particular that I want to highlight this with, not just encoders, but a lot of teams, especially young ones, they see that you can get a webcam or some kind of a camera or an Xbox Kinect, and you can use that on your robot to do computer vision. And that's one that I really have to caution, particularly young teams, because I've seen a lot of them try and do that, and it is very complicated, and you have to invest a lot of time and resources into it. And some of them have put so much time and resources into their cameras or other sensors that they don't end up spending enough time on the basics in terms of just driving really well or getting that shooter working really well or getting that arm to work really well. And so Kaleb's advice, I think, is really apt, where you just want to be careful that you don't get too ambitious with your sensors, assess where you're at, and make sure you take care of all the important stuff first, and kind of do the minimum number of sensors that you need to get the job done as well as you need it to. So thanks a lot, Kaleb, for that one. My apologies, everyone, but that actually, we're already at 8:03, so I'm 3 minutes over for the formal part of the webinar, and I think I got through most of the important questions, but I'd like to take a moment now to maybe switch over to the Q&A, the informal part where we can maybe address some questions from the audience. Paul, how have we been doing for questions, if you don't mind me asking?
We do have some questions, Sean. We have a question, a few questions from Laurie Bunch. His first one is, what language executes faster?
Oh my gosh, okay, so this one, panelists, please, feel free to disagree with me, but I'm going to take the first cut at this one. My impression, given the ones that I've been exposed to, is that C++ has been the fastest one. Java, not as much, because you actually do have to run a Java virtual machine on the RoboRio. And so for those of you who know what that is in the audience, there's a little bit of overhead involved with that. But it is true, like basically that RoboRio is a Linux computer almost running basically a pretty full Java virtual machine behind the scenes there. And you're basically just uploading a jar file. And so there's a fair amount of overhead with that. I don't have too much experience with Python. LabVIEW, it's a little tough for me to say, because I do have an experience doing the alpha test, and we had some concerns in terms of compile time, deploy time. Execution time seemed to be just fine. But that probably would have been my opinion on that one. Mark, do you want to chime in on that one? Because I think you probably have something to say with respect to LabVIEW, because you've got way more experience than I do, obviously.
Yeah, if the question refers to download time, how long does it take to download your program, then I would say that LabVIEW is not the fastest. But if you're talking about while the robot's running, speed, I have not seen speed be an issue. I've not seen a robot reaction time be slow or any of that. In fact, part of our programming practices is we have to slow the loops down so they don't use up too much CPU. So basically, the time of each loop is throttled or set by the programmer. So is that the question? Was the question how?
The question specifically is which language executes faster. And so actually with that one, I would agree. It's really independent of the programming language. I've yet to find a situation where it's really the programming language itself which is introduced so much of a time delay that there's a competitive advantage between any one of the programming languages. Like, Kaleb, did you have something to add to that one though? Have you?
Yeah, I would say the only I remember back in Recycle Rush, because everyone was trying to make their can burglars go within, like a millisecond or 10 milliseconds was a difference maker. So some teams looked into it on which one actually would, from enable, which one would actually run the fastest. And I remember, I think 254 made a post somewhere, but I think it was, either Java or C++ was one of the faster ones. But yeah, like in most normal scenarios, it doesn't really matter which one you use. They're all gonna, go at, like 20 millisecond loops or whatever you need.
Yeah. And I would say if you are seeing, a difference in execution time, it's more likely that you've coded something wrong. But yeah, I wouldn't say that the execution time is enough of a differentiating factor that you should choose one programming language over another, using that as your primary criteria. So some good information from all of our panelists on that one, but hopefully, Lori, that gives you a little bit of perspective on that one. But not substantially does one run that much faster than the other, to the point where you'll see a considerable advantage on the field. And I would say outside of that really special case of initial, like basically enable reaction time for those can burglars. But yeah. Paul, did you want to?
Yeah, so we have another question, again from Lori. He wants to know, does C++ programming for robots require a lot of work with pointers?
Okay. Yeah, C++ and pointers. This is always a bit of a fiasco. Inherently, you are going to use objects in C++, and so to a certain extent, to use objects in C++, like some people might disagree with me on this one, but to a certain extent, if you're going to use objects in C++, you've got to work with pointers to a certain extent. You can avoid it as much as possible by not trying to explicitly, use pointers on purpose to directly access memory and the like. C++ was an issue though with pointers when I first started using it with 188. I'll be honest with you, and it was probably one of the biggest reasons why we then chose to transition over to Java. Because Java really requires no pointers whatsoever. I mean, that's kind of, you're going to need to use pointers to a certain extent. You can't avoid it completely, unfortunately. Is it a lot? That's a bit subject for debate, but I think that answers your question enough, because a lot of, especially teachers, well, what they really mean to ask is, do you have to use pointers at all? And in which case, the answer is kind of yes, if you want to take full advantage of your objects in C++. And
his last question is, does C++ or Java give you an advantage to fine-tune your code?
Yeah, this is when you're probably going to need to hear from all of us. Like, I'll speak to C++ first of all. I generally felt that you could do whatever you wanted in C++. You could really get into there. Even the supplied libraries, the truth is that particularly, well, with all the programming languages, most of the program that you're going to do is pretty high level. You'll just be using functions and calls that are already provided to you in a library. and that library is called WPI-lib. WPI for Worcester Polytechnic Institute, the university where it was developed from. And so I know for C++ in particular, you could really access the source code for even those predefined libraries. And you could almost fork off your own copy and even modify those libraries if you needed to. So C++ gave you ultimate flexibility to fine-tune your code. We'll do Java and then LabVIEW. So Java, Kaleb, have you guys ever had to delve into the point where you really needed to really get your hands dirty by doing some low-level stuff and really fine-tuning it?
No, we primarily deal with high-level stuff and just use the built-in functions like the WPI-lib handles, like, setting motors or reading a sensor or stuff like that, and we just do all the actual, like control mapping and sensor PID and all that kind of stuff. But we don't really we haven't found a need to go like really low-level on the library or anything like that.
I guess I can speak to that one with Java as well, because on 6.10 we have had to sort of rewrite some of those libraries in the Java libraries. The source code there is available. It's not as difficult, but a little bit clumsier because you kind of copy and paste it and then you create your own packages. So the ability is there to do it as well. And so it can be done, but it's a little clumsier. And then now I need to pass this one off onto the LabVIEW side because I don't know what that process is like for if you really need to fine-tune stuff, and what if you really needed to mess around with some of the supplied blocks and libraries on the LabVIEW side. Mark, would you mind speaking to that one?
We've had to do some detailed stuff with the SRX controllers, but we typically don't dig in past the WPI library either.
Yeah. Becky, have you had any experience with that one?
No, we pretty much used what was provided for the most part. We did tend to use some other little helper things that I found just in the LabVIEW community. I mean, so we expanded upon just that, but it was like string manipulation and so forth.
I see.
But for the most part, just library.
All right, and I'm going to qualify my comments as well, because even though we did have the ability to essentially fork and tweak and tune the underlying libraries, Lori, that was also by far the most spectacular way I've seen programmers screw up a robot. And so, in a sense, the ability not to do it, depending on your skill level, is a good thing. But if you really want to get in there to mess with those libraries, because I've done some pretty impressive damage, or I've guided some students through doing some pretty impressive damage to our programming and our robots as a result of really fine-tuning it to that level. But it sounds like C++ and Java, I can tell you, up front that I've done it. It is possible. Not super difficult, a little bit clumsy, so there is a little, it sounds like there is a little bit of an advantage there, but a little bit of a disadvantage because you could really shoot yourself in the foot by taking it to that level at the same time. So tread carefully with that one.
We have a question from a young man by the name of Parth Patel, who has a question about built-in vision library. How good is it for each of the languages?
Great question. You know what, I'll take the first cut at this one, because with the vision stuff, I predominantly use Java. And the funny thing is that behind all the scenes for the Java vision libraries, they all end up being National Instruments supplied libraries at the end, which are basically the same libraries that are provided through LabVIEW. I've actually run into some situations where, what's made available in Java for those vision libraries is not as complete or as refined or debugged as what's available through LabVIEW. And so when I talked about fine-tuning my code and having to sort of really make modifications to the underlying libraries, it was a vision application actually that required that. And so that's a really interesting question on that one. Kaleb, have you guys done a whole lot of vision on 11.14 with respect to that question?
Yeah, we almost always we've always used the built-in Java vision libraries, which, like you said, just becomes NI vision at the end of it. But yeah, we found them, like you said, a little bit like incomplete, and some of the documentation for it is kind of missing for certain functions, but we've managed to figure it out and use it. Like we used it this year for our auto to aim to the high goal. Some teams like to use they'll use co-processors, but we like to keep everything just running off the RoboRio to try and, we don't communicate with network tables or anything like that. We just use all on board, all with the given libraries.
Yeah, same with us on 610. We tend to just keep everything on board when it comes to vision processing. And yeah, in terms of tweaking the WPI lib, I'm actually distinctly remembering it now. It was the NI libraries are what's going on behind the scenes for both Java and C++ anyways, but the Java libraries don't expose all the functionality and all the calls and all the parameters. And as we were kind of going through, what we wanted to do, we found that, the NI libraries, which are, the LabVIEW ones, fundamentally, they do support everything that we want, but it's this Java layer which is preventing us from getting to it. So we had to try and modify the libraries to get through to them. Becky, did you have too much experience with dealing with the vision on the LabVIEW side?
No, our team didn't get to using vision. We were starting that my final year, and we were just basically using what was there and just seeing like a live stream video. It wasn't anything more than that.
Yeah, Mark, how about on your end?
We typically start to mentor and a student, maybe two students will go off and start the vision process. But it hasn't gotten on the robot in the last 2 years.
Oh, okay, fair enough. Paul,
we have
another one?
We have a last question so far. This is our last one. It comes from Stefan Camilleri, a mentor from Rookie Team 6378. And I think it goes back to what Mark was talking about much earlier. Do any teams test code without uploading to the RoboRio, for example, using JUnit in Java or some kind of RoboRio emulator?
That's a really good question. The LabVIEW guys will have a field day with this one. So, Becky, we'll go to you first because actually I don't know if you've used these functions for LabVIEW, but I know it happens to be one of the strengths of the programming suite. But have you got some experience using simulators and being able to run your code offline?
Yeah, no, that's a big thing that we did, mostly because our team as a rookie team, we only had the one RoboRio. We couldn't share it, and a lot of times the mechanical guys were messing with stuff and they didn't want us to touch it. So that was one of the big things we always did, was run it in simulation mode first. A lot of our little things that were wrong we could find then.
Yeah, and Mark, did you take advantage of those in LabVIEW as well?
Yes, that's part of my training program, is that it allows us to take laptops, get them all installed with LabVIEW, and then we can sit and we can after we've taught them some the functions and how LabVIEW works, we can go in, we can build a project, and we can plug in our controllers into the laptops and actually drive robots around. And then we can say, okay, here's how we program a motor, here's how we program the sensors. Just so you know that it's limited to what the virtual robot has, which it can run mecanum wheels, it has a distance sensor on it, it has a gyro on it, and it has an arm that can go up and down that's attached to a servo and a clamp. And that's all you program. So if you're getting into advanced PID loops or whatever, the simulator is not going to have that for you, but it'll get you 50%, 60% there. For all my programmers, they know how to start with basically get everything working.
Yeah, and from my experience on 610 with both C++ and Java, I guess I'm just being honest here. Although I've been made aware that there are some simulation suites and tools out there that can interface with those programming languages, I personally never used them, and so I can't really comment a whole lot about that. Kaleb, on 1114, do you guys do any kind of offboard simulation without the robot?
No. Once kickoff happens, we start writing our code, and a lot of it would be similar to a previous year, so we just retype that, and like something like a PID class wouldn't change from year to year. But in terms of testing code, we'll run it and make sure it doesn't cause any errors trying to compile, and then after that, we usually have a separate drivetrain that we'll try and debug, sensors and get the drive code running until we get a full robot ready to go. But we don't use any sort of simulators or anything like that.
Yeah. So it sounds like the answer on that one does fall on a pretty clear divide between the text-based languages and LabVIEW, where the LabVIEW guys have a much more complete suite to be able to do that kind of off-board testing and simulation on the computer without actually having to upload it to the RoboRio. Whereas it sounds like you'll find the text-based teams, Java and C++, will just strictly rely on coding it and sending it to the RoboRio and seeing what you get. So, but that's a great question.
One more question, Sean. Again, comes from Lori. For C++ and Java, what is a typical program size in terms of the number of lines of code?
Oh gosh, this is a really great question. There's going to be so much variation on this one, and you might be surprised to hear some of the answers here. Kaleb, can I throw this one in to you at first? Because I actually don't know how many lines, say 610's last robot would have had. I actually wasn't involved with coding it too much, but Kaleb, this is a really interesting one because we're talking world-class robot here, 1114. How many lines of code goes into a high-quality robot like that?
Well, so like you said, it can vary extremely. Like I've helped out a rookie team and had them in a single file, and I don't know, maybe it was like 100 lines or less than that. But in terms of 1114, like I'm looking at our code right now, we like to separate things into different subsystems. Like we have different folders for everything and classes for everything. I think we have about like 80 files, not 80 lines of code. And then in each one of them, some of them could be 100 lines, but not all of them are that long. Some of them might only be like 40 lines. But combined code, I don't know actually how to count how many lines it is, but I would say definitely in the thousands.
Yeah, judging back from my 610 days, we're talking thousands of lines of code. On some years, if we had a whole bunch of sensors, a whole bunch of autonomous modes, it's quite possible to have cracked 10,000 lines plus because being the lead programming mentor, I was a little bit crazy about internal documentation. So for every line of code, there was probably at least 1 or 2 lines of comments, associated comments that went along with it, which is a little excessive for a lot of people's tastes, but totally necessary for me, especially for my style. But having said that, I remember my experience doing the alpha test in New Hampshire where, we were basically given a brand new experimental RoboRio, brand new set of programming tools, and they basically just told us, program what you can and get your world championship robot from 2013 running as best as you can using this brand new suite. And we basically wrote a program that was on the order of a few hundred lines. It was definitely less than 1,000 lines of code, a few hundred lines of code. And we had every basic piece of functionality on that robot working. To the point where, I don't mean to overstep my bounds saying this, but we probably could have put that robot out on the field and won, a few regionals or district events. I doubt we would have won, the world championship, but it would have been pretty darn good and good enough. So you can build some really good simple robots and program them super effectively without that much code. But it's got to be good code. Don't get me wrong. You're not just going to throw, sub 1,000 lines of random code together and expect it to work really well. But you have a huge amount of variation. But at that point, you're really not using any major sensors at that point. You might be doing everything more timing based, like Kaleb said, where it basically just runs some motors for a certain amount of time and boom, that's that. You may not automate a whole lot of things because I know for some of the higher level teams will automate a whole bunch of functions where you might press a button and it might spin up your shooter to a certain speed, set the angle on where it's pointing at, and also lock your position in place to make sure that your robot can't be pushed or moved around. It's those little sort of incremental nice to haves on your robot that end up eating up, the overwhelming majority of your coding time and lines of code. I don't know if you guys will agree with me on that on the LabVIEW side, but yeah, Mark, and any thoughts on that one in terms of smaller programs versus larger programs?
It usually comes down to well-architected programs are typically smaller than ones that have been kind of patchworked, I would say, that they've added this and then added that and then added this, but didn't really think about how to keep things organized. To Kaleb's point, we try and keep our stuff separated into subsystems as well, because a lot of times we'll get a mechanical failure and we'll have to shut that subsystem off, And if it's highly coupled into the program, it's hard to shut it off because it's maybe have some dependencies in there.
Yeah. Paul, how are we doing for our questions here? We're getting close to the end of our
We
time.
have a we have a really good question now from Alan Toms at Northview Collegiate in Toronto. Do any teams create several different autonomous programs depending on the partners you were teamed with?
Oh, yes, 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 yes. 100%. And this has come to the point, at least for my team, my old teams, we insist on having the ability to change our autonomous mode on the field seconds before the match starts if we needed to. And so what we've actually done is the controller that you use to drive the robot, when your robot is on the field and powered on, but it's been disabled, your program can actually still read the inputs on that controller. It's just that you're not allowed to react to any of the buttons. You're not allowed to spin any motors or move the robot. And so what we do is when the robot's disabled, we program some of the buttons right on the controller to be able to select different autonomous modes. And so literally when they're counting down the match, if we have a change of heart, if we see something on the field that we weren't expecting and we want to run a different autonomous mode, we just very quickly press a button on the controller just before the match starts, and we have the ability to switch it over. Kaleb, I'm pretty sure you guys do this as well in terms of your autonomous modes. How do you guys select? How do you guys select?
We do. We do the same thing where we have the controller. You can change which auto mode you're running, and it'll actually tell you on Smart Dashboard the name of the auto. In terms of number of autos, I remember in like 2014 we had maybe like by the time championships came, maybe like 20 different auto modes. You know, if you're want to run a 2-ball, want to run a 1-ball, want to play goalie using the Kinect. This year we actually decided to separate our modes. So the first part would be, okay, what defense am I crossing? Then the next part would be, okay, what position am I in? Am I all the way to the left? Am I on, position number 2, number 3, number 4, number 5? And then we had a third section where it was, okay, now what am I going to do? Am I going to low goal or am I going to high goal? So we actually had, because the field, I forget what they said at kickoff of how many possible configurations the field could be in, but we were able to have autos for all of those configurations without having to have actually, 100 or 1,000 autos all in a list. We just select each individual part and then it'll all get added together to run the auto.
That's pretty cool. So you basically put in a sequence of button inputs to select your autonomous mode. So you almost had to like punch in contra codes in order to select your autonomous modes. That's pretty neat. On the LabVIEW side, I think from what I recall, there are a few more options in terms of selecting them, where you don't even have to use the controller. You can set up custom dashboards. And maybe I'll talk about that very quickly. Kaleb mentioned something called a smart dashboard. For those of you who are familiar, there's a computer that you hook up your controllers to, and the computer is right in front of the drivers. So yeah, basically you drive your robot remotely by hooking up some USB game controllers to a computer, and then your computer basically wirelessly communicates to the robot. And then on the computer, it's running an application where you can get some telemetry, some readings and information from your robot and have it displayed on the screen. Something called Smart Dashboard is what the Java guys use to be able to show the information from your robot. And as much as I want to say great things about Smart Dashboard, it is really great and really useful. Sometimes I'm a little envious because the LabVIEW programmers have a different program. It's just called the dashboard, especially made for them and customizable through LabVIEW, where you can not only show information, but I think you can send information to your robot as well. Mark, is that something that you guys have done in the past with your teams, where you use LabVIEW to change up that dashboard?
Yeah, we in the last 2 years customized our dashboard. So we were setting our autonomous mode. They'd put the computer in, plug it in, and then they'd set the autonomous mode from the dashboard. They just drop down a pull-down menu and select their autonomous mode.
Yeah. And Becky, is that something that you've done as well in your previous experience?
Yeah, same experience as Mark.
Yeah, and I've seen some people get even more intricate than that, than just a simple pull down. But you could get pretty crazy where if you really wanted to, you could have a drawing of the field. You could click on buttons, placed around the field for different scenarios and this and that. But yeah, I think that's another difference that you'll see between the text-based languages versus the LabVIEW teams is even how you select those autonomous modes. Text-based languages will tend to do it more so through the controller and pressing buttons on it. The LabVIEW teams do have that ability now to actually just do it right on the computer that's connected to the field to drive it, where, yeah, it's simple as a drop-down menu. So some different tastes in terms of how you achieve that. Both really effective, but some really neat options that, I guess when you think about it, there are things which are very closely tied to what programming language you choose that normally I don't consider a whole lot. Paul, how are we doing for any remaining questions? Because we are actually out of time.
And we are done with our questions.
Oh,
wait a second. We just got one. Which controllers are teams using, Xboxes or joysticks?
Okay, we'll do this one really quickly because I feel really passionate about this one. I don't use Xbox controllers and I don't use joysticks. My team has always used, very specifically, the Logitech F310. I think it's called like a dual action gamepad. So it looks more like a PlayStation type controller. But we've been fiercely loyal to those. What we really like is that there's not much of a dead zone in the sticks, but there's two sticks, one for your left thumb, one for your right thumb. It's got a nice long cable, and you can hold it in your hand. So if you need to move around as you're driving, because sometimes things drive right in front of your face and you can't see around them. So if you're bound to joysticks that you have to leave right on the countertop, you can't really move left or right a foot or two to be able to look around obstacles. Some people really like the joysticks though because it gives you a big range of motion, but the Logitech F310, Logitech F310, I'll put, I guess, a great unintentional product placement on that one. Becky, were you pretty closely tied to any particular control method, or not really in your experience?
No.
Not really?
Not really in my...
Mark, how about you?
I'm a Logitech fan too. We use them exclusively as well.
Yeah, the game pads, right? Yeah.
Yep.
Kaleb, how about for you guys?
Yeah, 1114 has used the Logitech F310s as well. You could use an Xbox controller or a joystick. If your driver would rather have a joystick, then it's not that difficult to switch it up in programming of which controller to use. But yeah, just for the last as long as I can remember, we've used those Logitech controllers.
Yeah. So Alan, there's, I guess, a pretty direct answer to your question there. And I think we've got one more, Paul, that just came in. We can squeeze this one in.
Tank drive or single stick drive?
All right. I've had the first word on basically all the questions here, so I'm going to pass this one around. Becky, we'll go to you first. Do you really care in terms of the joystick layout on how you drive, tank drive or single stick or any other types of layouts?
No, I think it's more getting the drivers familiar with it and having them practice. You can't just throw something new at them. That to me is the big thing.
Kaleb.
I was never tied to one.
Fair enough. Kaleb, how about for you guys?
We've just done single stick, or as you might call it, arcade. But yeah, we've done that. It just gives you more options because now you can use the other stick for other stuff. But we could do either if we wanted to.
Mark, where do you stand on this one?
I think tank drive's a little more. You can do a little more fine motion because with the single stick, you have your left and your right and your throttle are all tied together. A little bit too coupled for me. But I have found it harder initially for students to learn how to drive a tank drive. The single stick's a little bit more intuitive.
Yeah, I would agree with that one. Surprisingly, a lot of kids who pick it up for the first time, they think tank drive is very intuitive and very simple, but I've seen a lot of them struggle with it the first time they do it. And then and here's what I would recommend actually, Alan, is a great programming exercise is to write a program that allows you to switch between the different layouts just by the press of a button, so that when you're doing your driver tryouts, maybe your drivers get a chance to figure out which one they're more intuitively comfortable with. And then on top of that, I'm going to throw in a third option there because this one I'm actually very passionate about. I have literally forced all of my drivers to use a relatively strange drive layout, which is not tank drive, which is not really single stick drive, but if you imagine single stick drive, but it's spread over two sticks where forwards and backwards is on the left stick, and then turning left and right is on the right stick. So if that makes any sense to you. This is, a lot of kids call this halo drive because it mimics sort of the movement type if you're playing the game Halo, where one makes your character walk forwards and backwards and the other one makes the character rotate. And so that one, just through a lot of years of just doing driver tryouts, when I've given drivers the opportunity to switch between them, I don't really know why, but it was statistically significant that drivers, whether they had experience or no experience, they, for some reason, were the most successful using that split stick drive, halo drive. And if you're ever in my circle of mentors and teams and buddies, we actually have a very specific name for that drive. It's called CADGE drive, named after a 5-year driver on Team 188 named Kajivan, who suggested it to me as a grade 9 student when I was a programming mentor. He just said, hey, can I just try this for the fun of it and split single stick into 2 sticks? He did it, and he absolutely rocked the tryout and just crushed everyone else and was our driver basically forever up until after that point. But yeah, it's one that I would recommend. Some teams, a lot of teams who try it for the first time, they end up swearing by it. But tank and single stick, if you don't believe me, try them, and it's a good programming exercise nonetheless. All right, Paul, I think we're past time here. Is there anything left for us?
No.
All right. Well, I wanted to take a moment just to thank all of our guests who were on with us tonight. Really, really appreciate it. I learned a lot about, I learned a lot about 1114 and how you guys operate over there, which is something that I've always wanted to know. I learned a heck of a lot about LabVIEW as well, which is something that I don't have a whole lot of experience with, but I think fills a pretty important need for those teams without a whole lot or any programming experience, because it is one of the things that teams struggle with the most when it comes to building and programming these robots. So I really appreciate the expertise of both Mark and Becky on the call. And I just want to remind everyone that next week's webinar is actually on kickoff. And so you'll learn a little bit about what you can do to prepare for kickoff, what kind of goes on at kickoff. If you're involved with the quick build, which happens after kickoff for our rookie teams, what to expect there. And unfortunately, I will not be able to be with you guys on that webinar, but I'm leaving the webinar in the very, very capable hands of Mr. Paul Keenan to be able to lead. But be sure to join us next week to be able to get a handle on kickoff and the whole process and song and dance revolving around that. But thanks, everyone, for your time, and have yourselves a great week. And thanks, panelists. We really appreciate it. Have a great night, guys.
Good night.
Thank you. Bye.
Thank you.